So today we have a great speaker, Claire Day, and Claire is a clinical social worker with over 20 years of experience in long-term care and is a professional educator in dementia. She has worked for the Alzheimer's Association for 21 years, the last 5 of which she was Chief Program Officer for the Northern California, Northern Nevada chapter. In 2018, she was appointed as the chapter lead for the U.S. study to protect brain health through lifestyle interventions to protect cognitive function in older adults. With more than 6 million people living with Alzheimer's in the U.S. alone, Claire will provide the most recent data on the prevention, early detection, diagnosis, and therapeutic interventions, as well as the latest advances in clinical trials available for Alzheimer's and other forms of dementia. And what a trooper Claire is to join us today. She has contracted COVID, but she is so tough. She's not going to pass this opportunity up. So Claire, take it away. Thanks.
Thank you. Thanks so much, Tom. I just want to confirm that everybody can hear me as well. And I'm sure someone will tell me if they can't, but yeah, so I do apologize. I'm a little stuffy, but overall doing pretty okay. So thank you for inviting me today to talk about one of my favorite topics to talk about, which is advancing the science around Alzheimer's and dementia. And, you know, I used to love it as I was in my sort of 20s and 30s that we would start to be able to add to our resume of experience. And then when I hear 21 years, I start to think, oh, maybe I'm going in the wrong direction now. But I think about the advancements that have happened over those 21 years that I've been with the association. And I'm going to share a little bit of that with you today. I'm also going to share some information around some things that we can all be doing today. The Alzheimer's Association's work is about people and science, and our logo reflects that. If you've ever seen the little squiggly lines, that's what it's talking about. The left side of the little squiggle really represents the person. We are leading the way to provide care and support to all affected. But then the right side really indicates that flask, that science need to drive risk reduction, early detection, as well as accelerating global research. So we are going to talk today about where we are, what we know today, what we know about early detection and diagnosis, and what's changing there, because it's really exciting. And also hear some of the latest advances. Every year we have an annual conference called the Alzheimer's Association International Conference. That's where the brightest minds in Alzheimer's and dementia science come together. And we have some interesting science results that came out of that. So I'll share a little bit about that too. But I always like to start with a little bit of level setting. And so I do always like to make sure that I start helping people understand the difference between Alzheimer's and dementia. We often use these two terms interchangeably, but there is a distinct difference. Dementia is what we call a syndrome. It's really that umbrella term that's used to describe a range of symptoms associated with cognitive impairment. And it can include behavioral changes, obviously those memory and cognitive changes, as well as psychological symptoms. These changes are due to a biological change in the brain, and the biological change in the brain is what's underneath that umbrella. So if you imagine the word dementia was replaced with the word flowers, underneath you would have things like roses and tulips and daffodils, all different types of flowers. All of those terms underneath are the same. They're different biological changes in the brain that are causing that loss of function. And that function is of enough severity that it impairs our ability to do our activities of daily living, like bathing and dressing and going to the grocery store, managing our finances and our households. Alzheimer's disease is the most common type. You can see under the umbrella that's obvious. And unfortunately, it's not uncommon that people have more than one type of dementia. They might have a vascular dementia, which is the dementia associated with having a stroke, and then develop the biological changes that occur from Alzheimer's disease. Now, we talk about all of these things because the facts and figures are pretty staggering. And And I don't need to go into a lot of detail to show you that. I think these numbers really speak for themselves. And you heard Tom mention it earlier, more than 6 million Americans are currently living with Alzheimer's disease. I think what's staggering is over 11 million Americans provide unpaid care for people living with dementia. We know that care and support for people living with the disease is at an all-time high need and is very stressful. And I think the cost of care, to me, is what's so staggering. In 2022, Alzheimer's and other dementias will cost the nation $321 billion. So when we talk about risk reduction, that's why we look at that. If we were to forecast out to 2050, it could rise to nearly $1 trillion. Those are words that really only seem real in games like Monopoly, but here we're talking about real figures. And this isn't because there's fancy treatments or expensive tests. It's because of the day-to-day care that is needed for people living in the moderate to late stages of the disease. And that care really comes at a continuum. When we talk about Alzheimer's disease and we talk about it being on a continuum, that means that these changes are happening over time. Everyone will start off what we call asymptomatic, meaning they have no cognitive symptoms, but possibly some of those biological changes that I talked about earlier are beginning to happen in the brain. Mild cognitive impairment is due to Alzheimer's disease, means that someone is living with the early stages of cognitive loss, but it's not necessarily impacting their activities of daily living. You could see those changes on a test, on a cognitive test, but they're able to function relatively independently. Someone who may go on to develop dementia due to Alzheimer's disease then is passing through an additional phase, which means that they may experience mild, moderate, or severe stages of the disease, of dementia, I should say. What's really important about this slide in particular is that everyone who develops dementia due to Alzheimer's disease or in these mild, moderate, or severe stages will pass through mild cognitive impairment. But not everybody who develops mild cognitive impairment will go on to develop Alzheimer's disease. So if we can prevent new cases of mild cognitive impairment, we can prevent new cases of dementia. And so I'm going to talk about some research that's really kind of leading the way around that in just a little bit. And you can see here that these mild, moderate, and severe stages obviously progress. Care becomes more of a need, interferes with more of these activities of daily living. So let's spend a little bit of time focusing specifically on Alzheimer's disease, because it is the most common type of dementia. And I think it's helpful to understand the true biology underneath it. So you're going to have to dust off your biology skills as we start to think about what these images look like. But I think it's also really important because this shows you how it is a biological change that's happening in the brain. Oftentimes, the symptoms associated with cognitive decline, like Alzheimer's disease or dementia, feel like they're around functioning and memory and behaviors. And so we often think about them as sort of mental health issues. And yet here is the evidence that shows the biological changes that are happening in the brain that are causing these. And I always like to show these images because it's kind of obvious then to see how someone with advanced Alzheimer's would have so much trouble when you see the differences between these two sides of a healthy brain versus an advanced Alzheimer's brain. Alzheimer's is defined by 3 hallmark changes in the brain. That's the presence of what we call beta amyloid plaques, tau tangles, and that neurodegeneration, or what we call nerve cell death, in areas of the brain that are really important for cognition, for memory, and for behavior. These plaques, also known as beta amyloid plaques, are a buildup of a protein that sits outside of our neurons. Neurons are those things that send and receive messages that help our brain function every other part of our body. And there's cells within our brain. And then there's this other type of protein called the tau protein. And changes in the tau protein can actually create a tangled web within your brain. Think of the tau protein as a transport system within your brain. It takes messages from one side of the brain to the other. And in a brain with Alzheimer's disease, that transport system gets impacted, and so the messages can't go anywhere, and then they kind of create this mess within the brain. And then inside the cells, we'll see that decreases their sort of neuronal cellular communication. This transport chemicals and nutrients across the cell. It impacts the ability to transport these chemicals and nutrients across the cell. So just a little bit of understanding to see what is happening within this brain. Now, all of these can't be necessarily seen on tests, although science is catching up with some of the tests that can be used to show working functions of the brain. But these were sort of post-autopsy cell examples that you look at through a microscope to see this level of detail. Now, it's important as we start to think about Alzheimer's disease and dementia that we also talk about what impacts our risk of developing cognitive decline or dementia. We like to think about it in two ways. There's these things on the left side of the screen here that we call non-modifiable, right? We can't change them. We can't change our age. We're all getting older every day. We can't change our genetic makeup. We can't change our race or ethnicity or our sex or gender at birth. But then there's these things on the right-hand side that are also showing some research to see how they may make up our risk in that what we call modifiable risk factors. So things like drug abuse or substance abuse, education levels. Coming out today and watching a presentation like we are today is a great way to decrease your risk of developing dementia, because you're using all of those neurons in your brain by learning something new. A lot of research is looking at traumatic brain injury, looking at physical activity, our cardiovascular health. What's good for the heart, we're learning is good for the brain. There's also some emerging research around exercise, around diet, around sleep. And they're looking at sleep from a couple of different angles. They're looking at the quality of the sleep that you get, as well as the length of sleep you get. Are you getting too little or even too much? What's the sweet spot for enough sleep? And then when we talk about quality of sleep, you'll hear words like sleep hygiene be entered into the conversation. What does that mean? Putting our phones downstairs and not looking at those blue screens before we fall asleep on our iPad or our phones. Thinking about things like sleep apnea, people who have sleep apnea and an increased risk of developing dementia. And some of those things are modifiable. One of the things that I like to kind of point out right here when we look at, obviously we talked about education, but cognitive and social engagement are also just as important. But looking over here at some of these environmental lifestyle factors, and I like putting this one right close to that non-modifiable risk factor as well. Because while we can choose where we live sometimes, not everybody can. And there are studies that are looking at things like air pollution and the quality of air. And whether it's because you have a job or because of where your family lives or just because of your socioeconomic status, sometimes dictates where you can and cannot live. And so while it's technically a modifiable risk factor, we also know that some people just can't change where they live because of where they work or because of where their family is, et cetera. So over time, we're starting to see emerging research really look at what these risks could look like. And it's really important to study these risks from all angles. There can be lots of different reasons why these are all unique to everybody. We always talk about the risk of dementia, and we talk about the progression of the disease, that if you've seen one person with Alzheimer's disease, you've seen one person with Alzheimer's disease. Our brains, the most complex organ in our body, are different. Other things can impact the progression of the disease, whether it's our own other health issues, whether it's contributions of some of these risk factors. So it feels daunting and it feels really heavy. And I like to get these first slides out of the way before we start talking about some of the stuff that I think is fun and exciting, because it is an exciting time in research. And even though sometimes we hear nothing but the failures when it comes to research, we know that there is still emerging science that's getting us really excited. So I'm going to share some of those things with you now. So the first thing I want to talk a little bit about, where we've made some significant improvements, is around early detection and diagnosis. So we know today that about 50% of people living with Alzheimer's disease have never been formally diagnosed by their healthcare professional for lots of different reasons. Sometimes is it we don't see the warning signs, right? We have those blinders on that stop us from really seeing the progression or the changes in someone. Sometimes it's lots of different reasons why we might not get an early or accurate diagnosis. But why it's important is because it can have emotional, social, and medical benefits. It helps us to understand the symptoms, to know what's coming, to think about what treatment options are available. And especially when we start talking about some future treatments, early detection is key. And understanding the type of dementia you have is also key. It can improve health outcomes. So what do we mean by that? There was a recent study, which I think I have a slide on, so I don't want to go in too much about it, that really looked at whether or not people could improve their health outcomes with an early and accurate diagnosis. It can help us to prevent complications, but it also has this ability to allow people to make their own legal and financial decisions, to think about what their care plan would look like, to participate potentially in emerging science and clinical trials, and hopefully manage some of that cost of care, right? When we don't know what it is we're caring for, the chances that we have an ER visit might increase. And so early diagnosis is really important to not just the Alzheimer's Association, but I know some of you might not be from California, but those of you that are joining from California, the California State Department has invested in us helping physicians really understand what early diagnosis and detection can look like, and arming them with the tools to be able to do it through a project called Dementia Care Aware. And it's also exciting because while today there's not one single test to diagnose Alzheimer's or dementia, there is some emerging science that's changing that. And one of those things are through things called biomarkers. Biomarkers are changing the game when it comes to not only accelerating the speed of research, but also looking forward to what diagnostic could look like in a medical practice. Now, it's important to know these biomarkers are not available in a clinical practice today. However, we're getting closer and closer to what that could look like. So you may not be familiar with the term biomarker. Essentially, a biomarker is a part of you. It's a biological part of you that can show disease. So if you think about, you've probably had a blood draw to test for your cholesterol level or to look at your glucose numbers. Those are all considered to be biomarkers, right? We can take that blood sample, and from that blood sample, we can detect whether or not you have the evidence of that disease, whether that's high cholesterol or whether it's diabetes. We're getting closer and closer to a simple blood test that could do the same thing for Alzheimer's and dementia. We're also seeing some other biomarker advances around things like brain imaging, but from the use of a positron emissions tomography or a PET scan, right now not being used in a setting where it can be covered by insurance, but is being used in clinical trials. And blood biomarkers are doing the same thing. And why that's important is because if you're using nothing but a history and physical to diagnose someone with potentially having the biological markers of, let's say, Alzheimer's disease. So if you remember back to that earlier slide, we're talking about the amyloid plaque. You have to have the presence of amyloid plaque in order to have Alzheimer's. The new treatments are all looking at attacking the amyloid, right? So if you don't have the presence of amyloid, the drug's not going to work. And prior to some of these biomarkers being available for clinical trials, we were making a guess based on history and physical and ruling out other things, just as we do in your doctor's office today. But these biomarkers are really going to change the game. We've got some that are looking at retinal scans. They're not quite as advanced. as some of the other things like PET scans and blood tests. But what's exciting is that we could one day be able to walk into a doctor's office and actually get one of these scans or have a blood test that would tell you definitively whether or not you had Alzheimer's disease. Think about the changes to patient care and changes to the benefits around early detection. And this is also interesting because when we think about what this does to modernize the diagnosis, what we've learned over the last several years is that these changes, these biological changes that are happening in the brain, are happening 20 plus years before any cognitive changes happen. So now we have to kind of imagine a world where we have a therapeutic, a drug perhaps, or a cocktail of interventions that could stop that cognition, those cognitive changes from happening. And you have the biomarker test to be able to show that the presence is there. It could be a real way to modernize the way we diagnose it and treat Alzheimer's and disease in the future. Right now, we're still over here. We're still with this history and cognition. So if you're suspecting that someone you love or someone you know has Alzheimer's disease or dementia, they'll go to their physician's office and they'll get a battery of tests that include blood tests to look for any kind of infections. And they're going to look at scans, but they're going to look at MRIs or CAT scans to see if there's anything that could be causing the symptoms, like a tumor or some sort of stroke damage on the brain. They're going to do cognition tests. So they'll ask you questions like, counting backwards from 100 by sevens, I can only ever get to 86. So those are the kinds of things that are then become very subjective, right? So if you're not good at writing a sentence or you're not good at math, you might be you might be tested, fail some of these tests that might not actually be representative of the biological change that's happening. So we're still sort of stuck over here on this right side, but these biomarkers this is where it will really help us to modernize the way we think about diagnosing Alzheimer's and other dementias, the way other diseases are diagnosed today. So I mentioned about PET scans. The PET scan is this can actually help to diagnose these and treat memory conditions. There are actually two types of PET scans used, both a amyloid and a tau. So remember those two hallmarks of the disease. There's different tracers. That's the measure that they use to show whether or not someone has evidence of that disease on a scan, but again, not available in your doctor's office today unless you want to pay out of pocket for it. Now, there was a clinical trial that's concluded that's actually expanding, that's actually helping to justify why Medicare should be paying for these PET scans to diagnose some of these cases of Alzheimer's and dementia. So something called the IDEA study, which stands for the Imaging Dementia Evidence for Amyloid Scanning, supported not just by the Alzheimer's Association, but through the American College of Radiology, as well as the Center for Medicare and Medicaid Services. This was a nationwide study that looked at over 18,000 Medicare beneficiaries who all had mild cognitive impairment or dementia of uncertain cause. So the hypothesis was that whether or not a PET scan could lead to significant changes in patient management. Now, what's really interesting about this clinical trial was that you can see here that people that were not diagnosed with Alzheimer's, who had the positive amyloid scan, so that meant they had amyloid on their brain, went up from 80% to 95%. So that means people were underdiagnosed here, right? Where they were told that they didn't have Alzheimer's, but they really did, right? So the other tests didn't quite show it. But I think what's most effective is this side here, this green side, where people that were given a diagnosis of Alzheimer's disease actually did not have evidence of amyloid on a scan. That decreased from a rate of 71% to 10%. So misdiagnosed, right? Whether that's because they had something else going on or whatever the reasons might have been. And so what we're going to do with this study is actually expand it to something called new ideas. We love our acronyms, to be able to continue to look out at people who receive these scans, hopefully recruit more diverse participants. Because diversity, equity, and inclusion when it comes to Alzheimer's and dementia research is a little lacking. As you can imagine, we have a lower number of people participating in some of these clinical trials who are African American and Latino. However, African Americans are twice as likely to develop Alzheimer's. Latinos are 1.5 times more likely to develop Alzheimer's. We don't know exactly why. Research is trying to answer that question. There's some thoughts around whether or not it's got to do with lifestyle, whether the cardiovascular risks play a factor. One thing we've learned is that genetics don't play the same role for whites as they do for Black African Americans. And so these types of trials, making sure that they have representation in them is very, very important so that diagnosis can be found for all, and then effective treatments can be found for all. So if there are different risk factors, we have to think about that as well. So I mentioned about the blood test, and the race is really on at this conference AAIC in 2021. That was the first time we saw some of this data presented, and we saw even more of that this year. What's great is that this data is matching up pretty close to a PET scan. So you're seeing the actual results on a PET scan compared to what these blood tests look like. What has to happen now is they have to be able to figure out how to make this marketable to physicians. So I learned a lot about blood and plasma when I attended AAIC. You have to think about how the blood is drawn, what kind of a container is it stored in, what temperature is it tested at to ensure that those results all match up. And so that's sort of where they are with some of this research, to ensure that we have the right setting to be able to really make sure that these tests are accurate. So it's exciting to see early detection and diagnosis really getting some legs in and really understanding the importance of it. But there's other progress that's being made as well, towards not just effective treatment, but also around risk reduction. So we're going to switch gears a little bit. I want to show you a slide that really helps you to understand the timeline of why it's taken so long to get where we are. Part of it is funding, right? So Alzheimer's and dementia funding prior to 2011 was sort of stagnant at about $500 million annually to the NIA. Sounds like a lot of money to me, but when you think about Alzheimer or research, $500 million is not a lot when it comes to really finding effective treatments. So now we have seen this great process through something called the National Alzheimer's Project Act, which has helped to increase some of that funding. And we're up over the $3 billion marker now every year that gets funded into this pipeline, this therapeutic pipeline that the National Institute on Aging and Health invests in. But it's important to think about how long this takes, right? So we're talking about years to decades, depending on the phase of the drug and the phase of the trial. We start to see in this preclinical work, this is lab work, right? This is where they're looking at cellular levels and they're looking at animal models before we ever get to test in humans. And phase 1, which lasts for a couple of months, really starts to look at safety and side effects, an important part of all research and why it's so regulated. Once they sort of get some sort of baseline data in phase 1, trials will move on if they're found to be effective into what we call phase 2. This can last anywhere from months to years, depending on the drug or the intervention. We're going to see more volunteers being recruited into those clinical trials. This is where we also keep looking at safety, but they also start playing around a little bit with dosage, right? So when you go and get a prescription filled, there's a certain dose that has the best impact for you. And so they'll do tests with different dosings to see if a lower dose has just as much impact as a higher dose. And once they've played around with that, then we start to see some positive impact from those. We start to move trials onto what we call phase 3. These are large trials. These should be hundreds and hundreds, if not thousands of participants to really test whether or not this intervention is working. And we start to see those can go anywhere from years to decades to really get statistically significant data. And I say all that just to say, we know that it takes a long time, and it's why I think it's taken so long to find some advances in science. And we've still got a long way to go. We recognize that. But what's now good is that we see so many more targets being tested, therapies being tested in clinical trials that target multiple aspects of Alzheimer's biology. Most of the mechanisms involved in Alzheimer's are being investigated in clinical trials. And so when we look at the entire pipeline, we're not just seeing drugs that are targeting amyloid in the brain. That used to be the theory years ago, but now there's over 100 unique therapies that are being tested to target all kinds of different things, including not just the amyloid beta, but tau, drugs that are targeting cellular communication, bioenergetics of the cell, as well as how they use energy, looking at neuroinflammation, vascular stress of the health on those blood vessels in the brain. So we're really sort of in this point right now where we look at no stone being left unturned, which is what we're going to need if we're going to find an effective treatment for everyone. So let's move on and talk about some of the updates from the Alzheimer's International Conference. And I want to make sure that we also allow plenty of time for questions. So this conference was just held in early August in San Diego, brought together almost 10,000 scientists, both online who attended the virtual, as well as more than 5,000 people in person. And one of the plenary sessions was looking at astrocytes. This is one of the immune cells in the brain, and looked at how astrocytes change their structure and function in people who have Alzheimer's and Huntington disease. It's another type of dementia. The changes to immune cells in the brain can be beneficial or detrimental. So it was really interesting to see that in the past, these immune cells have really been looked at as sort of this passive bystander that doesn't really do anything. What this study showed us is really that they can control complex behaviors, and they really are an active contributor to neurological disease. So this is one of those studies that is sort of those cell lab studies that really, though, will then potentially impact research in other areas down the road from the findings of some of this early science. There's also been a lot of science looking at the impact of COVID-19 and the pandemic on memory and thinking. And it really looked at COVID-19 is in general being studied around its impact on the brain. And we've heard people talk about, that sort of that fog, right? That memory fog of people that have the long-term long COVID, and people talked about the impact of what having COVID-19 did on their memory and thinking. One of the studies looked at whether or not in those who had long-term cognitive impairment, that had long COVID, and rather than looking at the severity of the disease of COVID when you had it, the severity of the symptoms, those who continued to have this persistent loss of smell might be a better predictor for long-term care impairment down the road. Then those, people think, well, if I had a really bad case of COVID, am I at an increased risk of long-term cognitive impairment down the road? And it's important to know this is all obviously very early stages, because until 2020, we really didn't study COVID. We didn't study any of these things. We also saw that being female and not working, and people that had a lower socioeconomic status during the pandemic, that's associated with more cognitive symptoms. So research looking into the psychosocial impacts of the pandemic in general, less about COVID. But there was also some good things, right? We saw positive life changes. And when we start talking about that focus on risk reduction next, we saw people that were getting out more, and they were making opportunities to stay connected to their friends. And so that might actually may reduce some of the negative impact of the pandemic itself. And so I think what's important takeaway here, obviously, when we think about that persistent loss of smell, remember I mentioned a few earlier about inflammation being one of those areas of study, that inflammatory response in people who had COVID, like loss of smell, may very well increase dementia cases in the future. And very important to know this is early research, but it's something that not only the Alzheimer's Association, but other organizations like the World Health Organization have come together to say, we can't not study the impact of COVID-19 and the impact of the pandemic on memory and thinking. So this wouldn't necessarily be, related to the hallmarks of Alzheimer's disease, but different types of cognitive loss down the road. So very interesting stuff, very early stuff. More reason to kind of get out and think about some of these things that we can do to protect our brain. And we know that 40% of dementia cases could be prevented or delayed by targeting those modifiable risk factors. So this is the really fun part of the presentation where you can all assume I'm going to tell you to eat right and exercise and stimulate your brain. But there was also some really easy changes I think that we could all be making, as well as some really interesting facts around ultra-processed foods. So let's start by focusing on that one. So ultra-processed foods were studied on their impact on dementia risk. And we know from some earlier studies around things like the MIND diet, MIND, which is looking at dark green leafy vegetables and omega-3 fatty acids and berries and nuts and all of those things that seem to have not just good heart health, but good brain health. But looking beyond that to some of that more negative stuff that we're eating. And what this study in particular found was that consuming more than 20% of your daily caloric intake in these ultra-processed foods is associated with a 28% faster decline in global cognition scores. So when they looked at testing people's memories. So what do we mean by ultra-processed foods? It's all the things that you think about, right? These prepackaged foods, things where there's 100 ingredients on them and you can't pronounce any of them, that are high in sort of a lot of these chemicals, and not chemicals, but preservatives and things like that. And I think it's a little concerning because ultra-processed foods make up about 50% of American diets. It's kind of a troubling statistic. But what they found from this study is it's also never too late to incorporate some of these healthy actions into your lifestyle, reducing some of those ultra-processed foods and adding in some of the good stuff, no matter how old you are. And that's sort of been some of the study that's come out around these risk reduction studies, is that it's never too late to start. Another study that was really interesting that provided results at the conference this year was something called the EXERT study. And what's really exciting about this study is, we've talked about exercise in the past, and they sort of have focused a lot of it on not just strength and balance, but also that regular aerobic exercise, right? We got to get our heart rate up if we want to have the maximum benefit. Well, what the EXERT study looked at was whether or not there were sort of two arms of the study. One looked at that aerobic intervention, but then one just focused on stretching and balance. What was great about this, and this was a study that was actually done with people that have mild cognitive impairment. So remember back to that continuum. They're in that little circle of mild cognitive impairment. So the cognitive changes are there, but they're still high functioning, right? They're still not impacting their daily life. you remember the other thing I said, if you can prevent new cases of mild cognitive impairment, you can prevent new cases of dementia. So it's really exciting that we're studying mild cognitive impairment, because what this takeaway was that both arms, both the aerobic exercise and the stretching balance, stalled cognitive decline in sedentary adults. So people that were in this trial were randomized into one of the two arms, all had mild cognitive impairment, all were not exercisers prior to the study starting. And what they found were both arms of the intervention stalled cognitive decline in those participants. So this comes back to that. It's never too late to start. And it's really encouraging because not everybody can go out for a walk and get their heart rate up every day or 4 times a week, or, and really kind of get their blood pumping, because they have other potential, physical ailments that might stop them from being able to do that. And some of this safer stretching and balance might be just as beneficial. So it's really encouraging. The next study I want to talk about really talks about those cardiovascular risk factors. And so we looked at a study called the Sprint Mind study. And this is one of those slides that I say, if you listen to anything I say today, pay attention to this one. This was the first case to demonstrate the reduction of new cases of cognitive impairment. And the study showed that you could potentially reduce your risk of mild cognitive impairment and dementia by addressing cardiovascular disease risk factors. And in this particular study, they looked at blood pressure. So there were over 9,000 participants, all over the age of 50, who were at an increased risk of developing dementia. So they might have been sedentary, they might have had diabetes, they might have high blood pressure already. And they were randomized into one of two arms. One is the standard, what was considered the standard intervention at that point of blood pressure monitoring, which is to kind of keep normal blood pressure around 140 systolic, that's that top number, versus what they called an intensive arm that was about 120 systolic. And what was great about this study is that they could use medication. So while they encouraged people to make lifestyle changes, they also allowed them to be on a medication to lower your blood pressure. And they found that people in the intensive treatment had a 19% reduced risk for mild cognitive impairment, a 17% reduced risk for dementia. And when they looked at both of those together, it was about a 15% reduced risk for both mild cognitive impairment and dementia. This is another one of those studies that's going to be continued with Sprint Mind 2.0 to really look about that dementia risk. We need to study people for a longer time to see the benefits or the impact on dementia, because dementia doesn't happen overnight. It's progressive over time. You start to lose some of these cognitive function. But it's really, really exciting. And now, if you were to ask your primary care physician, 120 is considered to be normal blood pressure. So a really big takeaway here is just to be monitoring those cardiovascular numbers, like blood pressure, like your glucose, all of those things that, excuse me, I thought I was going to sneeze there for a second, that connection to good heart health, good brain health. 25% of our blood pumps from our heart to our brain. So it makes sense, right? Now, what we want to look at is what happens when we put all this stuff together. We talk about the exercise and we talk about diet. There's a study that happened several years ago in Finland called the FINGER study. And the Alzheimer's Association launched in 2019 the U.S. study to protect brain health through lifestyle intervention to reduce risk, otherwise known as US pointer. So get it, finger pointer, right? Kind of going with that theme to replicate the study that was done in Finland. Kind of a big difference between people that live in Finland and people that live in the United States. But what it's doing is taking all of these scientific evidence around physical exercise, around nutrition, around that intellectual engagement, and the health coaching around blood pressure and diabetes and cholesterol, and randomizing people into two arms of an intervention. One is what we call a structure group, where they meet regularly. There's a team and they have a navigator and they have an intervention team that help guide them on a weekly and then biweekly, then monthly basis to make these lifestyle changes. Then there's the self-guided group, which are also given a navigator, but they don't meet quite as often. They're given the information and said, go make these lifestyle changes. And what we want to see is whether or not, if these interventions prove effective, whether it will lead to the development of accessible, sustainable, community-based programs for prevention of Alzheimer's disease. So we're not quite there yet. But you might notice of the 5 sites across the US, there is a little gold or yellow dot here in Northern California. And if you're interested in getting more involved in understanding how you might be able to participate in the US Pointer Study, the second site to randomize was at UC Davis in Sacramento. So perfect group to be talking to if you're over the age of 60, between 60 and 79, and you are looking at ways to get involved in decreasing your risk, especially if you are at an increased risk. What's really great about this, we're almost done recruiting. Even here in California, we've still got just a few more teams to recruit. But then there's also some supported ancillary studies that are looking at some of these other things like the neuroimaging. Do those scans match what we are seeing on the cognitive tests? Sleep. How is sleep impacted by making these changes? Looking at the neurovascular system as well as good gut health. All of these things, very, very important to help us identify whether or not we can reduce our risk of developing dementia. We know that a lot of studies really need to be not just funded, but we need those participants. So I'd be remiss if I didn't talk a little bit about that need for people to participate in clinical trials. And this just gives you an idea of the landscape. Trial Match is a matching service that can help if you are interested in joining a clinical trial. There's a little QR code here you can scan if you're familiar with those. This tells you right here what we're studying right now. This is nationwide. There's not just funded by the association, but funded by the National Institute on Aging and the National Institute on Health. Alzheimer's disease, 615 studies, 253 on that mild cognitive impairment. But we're also looking at vascular dementia and looking at other types of dementia so that we can understand what treatments will work for who and make the most impact possible. And why this is so important? Well, because we could really change the trajectory of the disease. In the future, treatment will most likely include everything, right? Combination of those medications, but also those risk reduction strategies. You think about those milestone birthdays. When you turn 50, you have your first colonoscopy and you're supposed to go and get a screening for breast cancer and other types of cancer. Imagine if we had the same type of intervention around protecting your brain health that sort of is prescriptive by your primary care physician. If we developed a treatment or delayed the onset of Alzheimer's by just 5 years, 5.7 million people expected to develop Alzheimer's in 2050 would not. We could move that line. And so it's why we don't leave any stone unturned and why all of these studies, even the ones that don't have statistical significance and don't end up resulting in something moving forward, they all have value because they help to guide then future researchers. I know I covered a lot in a small amount of time. If you're interested in some of the science, I would encourage you to download the Science Hub app. And this just lists some more research resources for you. We've made these slides available for you that I believe they'll be available for you. But it is exciting. I know it doesn't always feel like it. We hear a lot of the failures, but those failures lead to new interventions and really save researchers time. And I certainly think that there's a lot of hope in research and sort of helping us move towards our vision of a world without Alzheimer's and all other dementia. So with that, I'm going to stop sharing my screen. I think. I'm going to stop sharing my screen.
Thank you very much, Claire. This has been fascinating for certainly for me and the other attendees. Just following up what you said about clinical studies, I wanted to share that one of our attendees is actually in the Pointer study.
Oh, yay! Don't tell me
and-
anything about it.
No, I wasn't, and I was
the
leave the
participant.
individual anonymous. I was just going to say that the person's comment was that they're currently looking for more participants in age range of 60 to 79 without cognitive memory problems and not regular exercisers. So I'm just passing that on.
Yeah, no, I love that. And again, I think that's why I reached out just to say, is this generally the Sacramento? You guys are right there. We've only got a few teams left to randomize, and it really is a great. Hopefully, it sounds like they're having a great experience. I don't want to push them to tell too much, but because we are in the middle of the clinical trial, but hopefully people will really want to get involved. And if you just go to alz.org/US Pointer, you can find the information on how to sign up or how to get some inquiries about whether or not you qualify.
Excellent, thank you. Another question from one of the attendees is why do education, learning new things, and similar activities help reduce cognitive decline?
Yeah, I think that's a great question. So it's about really stretching those your brain, right? So making sure that those those neurotransmitters keep working. And so the research is showing us that the more active, even someone who's diagnosed with Alzheimer's disease, the more active they are, the lower the potential better progression they'll have. It'll be a little bit slower. And so the more we can do to engage our brain, the more we can keep those synapses firing. Evidence is showing us that it does have impact. And I think it's important to note that I recognize, and we all recognize, that you can do all these things and still develop Alzheimer's disease. Lifestyle changes are not the only answer. Genetics plays a role. Other things that we haven't quite determined play a role. But we also know that even if you have Alzheimer's, these things can also help you manage the disease a little bit better.
So there were several questions about, there's one question about Prevagen, which we certainly all see advertised heavily on TV. Another question about any pluses or minuses for alcohol in terms of affecting dementia. And then the third one, I'm kind of piling up a few questions here, higher fat intake and brain health. So I've just thrown three things at you, and
yeah,
thank you.
So, the thing about these supplements like Prevagen is there's really no evidence to say one way or another whether or not they are impacted or affected. They're not regulated by the Food and Drug Administration, so they don't have to participate in any sort of clinical trial. And, as an organization who prides itself on science, science is very important to us. We have to have the evidence there. Now, who's to know whether or not they're good or bad? There's just no way of really telling. And so, I always say to people to be sort of a savvy consumer and talk with your pharmacist and your healthcare provider. Some of these supplements can have detrimental impacts if you're on other medications, and just really sort of do a little bit of homework on, what their claims are and what they're really trying to say to whether or not there's anything there. The second question, now you're testing my short-term memory. The second question was about, oh my gosh, I've forgotten already.
One was about effects of alcohol, and another one was about high fat intake.
Oh, okay. I'm going to write that down. So interesting about alcohol, red wine in particular. If you were to do any of the reading on the original diet that we're using in US Pointer called the MIND diet, MIND, a glass of red wine was a good thing. It's sort of like a point system where you get points for good stuff and you get no points for bad stuff, right? And so now there's a lot of research that shows that one glass or maybe 1 to 2 glasses of red wine in particular, the antioxidants have shown that they have a benefit. We also know that excessive alcohol use certainly can cause another type of, that dementia related to excessive alcohol. So you have to find that balance. And, they talk a lot about with the diet, everything in moderation, right? So, but it's the the red wine in particular that seems to have the most benefit. And then excessive fat. I mean, I think what Pointer looks at and what we look at with the Mind diet is around balance. It's about limiting the bad fats, not cutting them out completely. I think that's what I like the most about some of these interventions is that it's about moderation. And we know that, when we think about diets that are high in fat, they can cause other cardiovascular risk factors that contribute to increasing your risk of dementia.
Thank you very much. There are at least another dozen questions pending, but I'm aware of our time constraints, so I'm going to turn it back over to Tom to wrap things up.
Well, Claire, you certainly threw a lot at us, and I appreciate everything you've done, and it's an amazing amount of information and so well put together. We really appreciate it. I'm sure that everyone's going to be wanting to go and tell their friends to watch this recorded and archived video today, because it's so helpful and so useful and so important. Also, Chris let me know that he is going to send out the PDF that you gave him to all of those individuals who have registered to watch this forum, whether they've done so or not. So thank you again. We appreciate everything you've done for us. And we're going to go through a few more housekeeping slides, but in honor of what you've done here, we are going to give you an honorary membership to the Renaissance Society. And we'll also make a monetary donation to the Seth Nelson Student Emergency Grant Fund. So again,
that's wonderful. Thank you.
Appreciate everything you've done. Thanks. And remember, all of these forums are recorded and they're archived. Again, as we've said before, go to the youtube.com and search for the Renaissance Society forums, or go to the Renaissance Society website itself and their homepage and just click on the recordings. Next week, we're going to hear about space debris from John Chryssidis. And it's just floating space junk. So why do we care? There's a lot happening in space right now. So I'm sure we're going to have a great audience to participate in that. So don't miss it. Thanks again, and have a good rest of your day.